Okay, continuing with number 4. Starting off, we want to factor, and the top can factor to 3 times x squared minus 16 over x, what is that, x plus 4, x minus 1. Now this top piece is a difference of two squares, which sometimes gets overlooked, but it can factor to 3x plus 4, x minus 4. And the bottom stays as x plus 4, x minus 1. Now I'm going to go ahead and cancel them. So this piece here and that there will cancel, and I'm left with 3x minus 4 over x minus 1. Now we need to list our domain. Our domain is going to be all reals, given that x cannot be. And now I need to look at the last one before I factored, right? So that's going to be, what is that, -4 and +1. For wholes, well, what canceled? -4 canceled, so I have a whole at x equals -4. I have a vertical asymptote at x equals 1. I'll go ahead and draw that on my graph. I have a end behavior asymptote. And this is our first time that we have a horizontal asymptote, an end behavior asymptote. We look here at the original, we have x squared on top and x squared on bottom. The bottom is like a 1x squared, right? So our end behavior asymptote is going to be y equals 3 over 1, or just plain old 3. Right? Eventually we'll expand the definition of an end behavior asymptote, but for now we're just going to look at the horizontal ones. And then we have an X-intercept. Right? We look at this one here, and we look at the numerator, and that's going to be at x equals 4. So I can go ahead and put a dot on the 4. Now we need to plug into a t-chart. So we have x, y. And we always have to, in our t-chart, we always have to list our wholes. So I'll start off with -4. And let's do like 0 and 2. And now whenever we plug them in, I'm just going to read off my notes from the other day. -4 gets 4.8, 0 is 12, and 2 is -6. If you have a hard time plugging these into your calculator, then please email me or let me know, and I can help you out with that. But now graphing these, we've got -4, 4.8, somewhere up there. 0, 12 would be somewhere up in that region. And 2, -6 would be down here. Ooh, and I just realized we didn't actually graph our end asymptotes. Let's do that at 3, something like this. So that should help us see it a little bit. We know that as they go with the asymptote more, as it gets farther away from like this little crossing spot, they're going to hug the asymptote, right? So this right swoosh we can see is going to do something like that. The left swoosh is going to do something like this. And I know it kind of goes off the graph, but we'll just go with it. Right? And that's that. Let's look down at number 5. Number 5, again, we want to start off by factoring. The top can factor to x minus 1 over 3x squared minus 5x plus 4. That denominator will factor again to be x minus 1 over 3x minus 4, x minus 1. I'm going to go ahead and write it down as canceled, so I'd have a plain old x on top, 3x minus 4 on bottom. Now for our domain, we're going to have all reals given that. And again, I have to look up here before I canceled. That's going to be x equals 4 and 1. Wholes. Ooh, hold on just a second. I don't think I did the last one correctly. Let's scroll back up for just a second. I'm sorry. Seeing holes made me think that. Yeah, we had a hole here, and I did not put that in our graph. I'm sorry. At -4, which is right here, we have to put a hole. I'm sorry. We have to do a little circle like that. Oops, maybe I can actually draw correctly. Okay, and that little circle there signifies that there's a hole, right? That's an easy thing to forget. Well, I forgot it, so let's go back to our current problem. We'll have a hole at x equals 1, and I'm going to just highlight that so that I don't forget to graph that correctly. We have a vertical asymptote at x equals 4, and a horizontal, or well, I call it an end behavior asymptote, an end asymptote at, what is that going to be, y equals 1/3. What else do I need to find? I need to find X-Intercepts. X-Intercepts, I look at my canceled version, this one right here, that's going to be just plain old 0. I can put a dot on 0 for my X-Intercept, and I can draw in my asymptotes. So we'll have 1/3, which would be something like this. Vertical asymptote at 4, so something like that. And then now we need to get a t-chart going. So we'll have x, y. And again, we always have to include our hole. So I'll have 1 in there. So that'll put, if I put 1, I'll have 2 to the left of this. Now I need 2 to the right. So let's do like the number 5 and 6. Whenever I plug in 1, I get negative 0.1 repeating. 5 gives us 1.6 repeating, and 6 gives us 1. So this time, whenever I plug in my hole, I'm going to make sure that I have a little circle here. So what is that? 1 is at negative 0.1, so something like that. So there we can kind of see that it's going to do a swoop, getting closer to the axis there, or to the asymptote there, and kind of like that. 5, 1.6 will be somewhere in this region, and then 6, 1 will be right there. So we'll have a swoop like that. And that's that. Let's do another problem. Number 6. Factoring this, I will get the top, I can pull an x out of it. And then what would the next factor to? That'll be x plus 1, x plus 2. The bottom will factor to 4x, x plus 4. This one's a little bit different. I don't think we've had one yet that the plain old x's cancel. So we'll cancel those, and then we have x plus 1, x plus 2 over 4, x plus 4. All right, now for our domain, it'll be all reals given that x can't be. The x plus 4 tells us negative 4, and the plain old x tells us 0. For holes, we look at what canceled. Well, the x canceled, so that's 0. So we have a hole at x equals 0. We have a vertical asymptote at x equals negative 4. We're not going to have an end asymptote. And then our X-Intercepts. Remember, I look at the factored piece of it. What would make the top a 0? That'll be negative 2 and negative 1. So I can put a dot at negative 2 and negative 1. I can draw in my asymptote at negative 4. And now we're ready for a t-chart. So we'll have x, y. To the left of the asymptote, let's do like, I don't know, negative 6 and negative 5. To the right of the asymptote, let's do the number negative 3, and we have to do 0 because that's our hole. Whenever I plugged in negative 6, I got negative 2.5. Negative 5 gave me negative 3. Negative 3 gave me 1/2. And 0 gave me 1/8. I'm going to do 0 first. I'm going to plug in an 1/8, a little circle like that. Did I mess up the hole in the last one too? No, I did not. Okay, good. Whenever I plug in -3 at a half, something like this, -5 is at -3, and -6 is at -2.5, something like that. All right, so let's talk a little bit about the end behavior of these, because this one we're not really seeing what's happening. I can pretty easily say that it's going to do some kind of swoop like this and some kind of swoop like this. But we want to talk about what happens at the end. We have x cubed and x squared on bottom. So if we were to take that apart, it'd be x cubed over 4x squared. If we were to cancel that, it would be like 1/4 x. So what that means is whenever we zoom out really far, our graph will kind of look like 1/4 x. Okay, so we kind of think about that. 1/4 x will end going up here, and it'll start going down. So that kind of tells us what the rest of our graph will do. Right, so again, if you looked at this and you kind of ignored this middle piece, the edges there would look like a line with a slope of 1/4. So that's kind of where we look at that. And this is technically an end behavior asymptote, but I'm not going to list it as that. We're just going to look at the horizontal version of it for now. Okay. Next year we'll look at the slant end behavior asymptotes. So that is that one. Do we want to do another one? You know what? I think that's enough for this one. So that's all.